Okay, so as we talked about in class, we are going to continue working on lesson 5.4, the slope formula. This was the definition that we talked about in class. It's the slope of a line is the ratio or the difference between the y values over the difference between the x values on two different points on the graph. So we talked about this and did some examples in class using the x1, y1 for our first coordinate and x2, y2 for our second coordinate. And you see that the equation, or the formula, is set up like so. And we talked about how to solve that and work through that. Now we're going to look at some of the examples on why we're doing that and how to do that. Okay, so let's take a look at this in terms of finding the slope of a line that contains the points 4, -2, and -1, 2. So we look at this in terms of what we had talked about. That's going to be our x1, and here is our x2. And then we'll use a different color here and identify our y1 and our y2. So when we set up our equation, we're going to end up with y2 minus y1, or set up our formula here. So this is going to be 2 minus a -2. And we're going to have our x2 minus our x1, which gives us -1 minus 4. Now, following our rules that we know how to use for adding and subtracting integers, we're going to get 2 minus a -2, which is going to give us the same value as saying 2 plus a +2. Keep change. And then -1 plus a -4. Should make things easier, so we're going to end up with 4 over a -5 for our slope. We look at our second example. We can do it the same way. We're going to take -2 minus a -2. Those are our y values. And we are going to take 7 minus a -2, and those are our x values. And now we can go through our steps for subtracting integers. -2 minus a -2 would be the same as saying -2 plus a +2, and 7 plus a +2. When we solve that, -2 plus 2 is 0, and 7 plus 2 equals 9, so we have a slope of 0 over 9. So those are two ways that we can use a slope formula for situations where we're given some coordinates. Now in the next step, we're going to talk about how do we use a graph or a table in order to find our slope. And we've talked in class a couple of times about how easy it is just to go ahead and count on a specific graph and count that we have 1, 2, 3, 4 over, and 1, 2, 3 up. So we have a 3 for a rise and a 4 for a run. Now we're going to talk about how we can use those coordinates to do the same thing. So in this case, we're going to take the information that we know. We have a coordinate of 2, 2 and -2, -1. And we're going to use our formula. So 2 minus a -1 over 2 minus a -2. And those are our x and our y values for each of those coordinates, just like we were doing before. So 2 minus a -1 is going to give us 3, and 2 minus a -2 is going to give us 4, which is very similar to what we just said here, was 4 spots and 3 spots, so that gave us a slope of 3 over 4, just like we were able to calculate using our formula. We can do the same thing on the second graph. We have 4, 3, and 2, 2, so we're going to take 3 minus 2 and 4 minus 2, and we're going to end up with 1 over 2, which is 1/2. And if we were to calculate this, 1, 2, 3, 4 for our run, 2 for a rise, which could be simplified, 2 over 4 to 1/2. So it's a nice, easy way to check it using the graph. We look at the table. We are just going to pick 2 of the points. It doesn't matter If we started with the beginning and the end, or if we chose points in between, as long as it is a linear function, it's going to be the same no matter what. So let's start with the situation we have here. So we have our x values. So basically we have a coordinate of 2, 0, and we have another one of 2, 5. And so we're going to get 5 minus 0 and 2 minus 2, which is going to give us 5 over 0, or a slope of undefined, like we've talked about in class. Okay, it's going to be a vertical line. In this situation, the second one below, we'll choose the two middle numbers in this case. So we have 2, 5, and we have 5, 11. And we can use our formula the same way. So 11 minus 5 over 5 minus 2, which is going to give us 6 over 3. And we can simplify this to 2 over 1. So we have a slope of 2. So there's additional ways that we can use the slope formula when solving for the slope using a graph or using a table. The last thing that we need to cover is when using an equation. And we talked earlier in the chapter about using your x and y intercepts and how to find your x and y intercepts, and this is where this is going to come into effect. So in this case, we have the equation 6x minus 5y equals 30. And we are going to try to find 2 points so that we can use the slope formula. So what we're going to do is basically the cover-up method. And I'm just going to cover that up and say 6x equals 30, which means I divide both sides by 6 to solve for x, and I get x equals 5. So I'm going to say that my first coordinate is going to be 5, 0. Then I'm going to solve it for y. So my original is negative 5y equals 30. I'm going to divide both sides by negative 5. Y is going to equal negative 6. So my coordinate for y is going to be, or my y-intercept is 0, negative 6. Now I have 2 coordinates that I can work with in order to find my slope. So negative 6 minus 0 over 0 minus 5. Negative 6 minus 0 is negative 6. 0 minus 5 is negative 5. Negative 6 over negative 5, which is going to be 6/5. Our second example, we can start the same way, rewriting our equation, and I'm going to do it twice, equals 12, and then 2x, to give you another visual of. I'm going to cover this up and solve for x. Divide both sides by 2. X equals 6. So my first coordinate, or my x-intercept, is going to be 6, 0. Then I'm going to solve for y. 3y equals 12. And y equals 4. So my second coordinate, or my y-intercept, is 0, 4. I can use those two to plug into the formula. 4 minus 0 for my y difference, 0 minus 6 for my x difference, and I'm going to get 4 over a negative 6, which I can reduce to a negative 2 over 3. So using a equation is much the same way as we've first got to find some points, and we can do that by using our x and y intercepts that we talked about how to solve earlier in the chapter. So that concludes lesson 5.4 on using the slope formula.